Hi, everyone. Thank you for joining this session. My name is Remus Moyes. I'm an engineering manager with the Amazon text-to-speech team, the team that powers Amazon Polly. And I will be talking to you today about the service, about the Polly service. Give a couple of tips and tricks about how to bring the Polly voices to life. And I will invite later during the presentation, I will invite to the stage the creator of one of Alexa's most popular skills, the magic door, who will also go through some of the ways some of the tricks he uses to create a magic experience using the Polly voices. How many of you here are familiar with Polly? Thank you. That's very helpful. It helped me calibrate my presentation. Okay. So I will talk to you about the service and how text-to-speech works a little bit. Then I will introduce some of the new voices that we have launched since last year's reInvent when we launched Polly itself. I will go through the couple of examples of how to control the voices, how to make them produce more than they normally do without SSML, and I will later go into what SSML is. Then we will go through explain how to get most out of Polly voices through the magic door, the example of magic door. And then if time allows, we will take some questions. Okay. Polly is a text-to-speech service. It converts text to lifelike speech. It offers 52 voices that speak 25 languages altogether. The Polly service is a fast service. It is fully capable of powering real-time systems, and it allows developers to create speech, to generate speech, and store it, cache it on their applications, within their applications or devices, replay it an unlimited number of times at no additional cost. Amazon Polly is easy to use. You can do that. You can generate speech through, in two ways. Either through the Polly console, which is available on the AWS website. It's a very simple GUI, and you can, it has two modes, either plain text or SSML, where you can specify, explicitly get a way of pronouncing certain things or many other features that can be unlocked through SSML. And obviously choose the voice that you want to generate speech with, and play or download the generated audio in a number of formats. And you can do the same through the API, which allows for a number of operations. And there's also a feature called a Lexicon, which allows for customization of pronunciations. And I will have an example later in one of the later slides. Okay, a few words about text-to-speech in general, about how speech is produced. Traditionally, text-to-speech systems can be looked at as a front end and a back end. Usually the front end is focused on text processing, and the back end is focused on the actual generation of the audio signal. And the first step of the front end is, well, text normalization, transforming any input text into a series of plain words. And based on those words and based on the relations between those words and so on, the system generates well, it's not only a phonetic transcription, it's a lot more than that. You can call it a linguistic representation of speech. It goes into it breaks words into phonemes, but it also takes into account many relations between these phonemes, between words. It matters when producing speech whether a given speech unit is at the beginning of the word, the beginning of the sentence. It influences intonation, many aspects of speech. And then based on this linguistic representation, the backend generates the actual audio, right? The signal.
100% recycled, 8.5 by 11-inch, 20 pounds office paper, 3,000 count.
That's what the Joanna voice sounds like when synthesizing this input text. And as you've seen, I mean, I chose one of the most complicated input texts I was able to quickly find. There are many challenges in text-to-speech. I mean, a text-to-speech system needs to deal with in order to synthesize speech just like a human would. And one of the challenges is the so-called G2P, which is short for grapheme to phoneme. It's transforming the written form into spoken form. It depends, I mean, the complexity of this system depends a lot on the language, with English being one of the most complex. I mean, Spanish is very straightforward. You can think of even a rule-based system that can get that pretty much any text right. But in this example, rough, though, and through, the same sequence of graphemes result in a different pronunciation. Other challenges are homographs, which are words written the same way but pronounced differently depending on the context, and live, live, or read, read, and so many more, and many more. And yeah, I mean, the difference between these two is that while for live in this context, you can pretty much understand it from the context. You need so much more in the case of I read this book. It can very well be I read this book, right? They're both correct. Fortunately, we have SSML to sometimes help the system. This complexity can also appear at the text normalization level, where you have homographic abbreviations like ST dot, which can be expanded both as street and saint, and many other many other challenges depending on the language. I don't want to go into the challenges of the Japanese writing system, which is by far the most complex one. But even for English, right, you have a lot of you have many intrusions from other languages which need to be pronounced according to the pronunciation rules of the language of origin, or non-standard words. Yeah, and I will let the new Amazon Poly voices speak for themselves.
안녕하세요. 제 이름은 서연이에요. 리인벤트 2017에 오신 것을 환영합니다.
This is a new addition to not only our portfolio of voices, but also languages. It's our first Korean voice.
Hi, I'm Matthew. I'm a new addition to the Poly voice portfolio. I do great impersonations of Batman.
That's true. I mean, really.
はじめまして、Amazon ポリーの声の仲間入りをしました。水木と共によろしくお願いします。
Takumi adds to the already existing female Japanese voice, Mizuki. and as a result of the feedback we got from customers who requested a male voice for a male Japanese voice as well, we listened to your feedback, and we definitely include that into into our prioritization and roadmap, and this is the result of that.
Hallo, mein Name ist Vicky. Willkommen bei re:Invent 2017.
Vicky is a new German voice, which does very well with the so-called Denglish. Denglish is it's what Germans call the frequent intrusions of English words into their normal day-to-day speaking. We got really good feedback on the voice from customers who say that this is the best German voice available on the market.
Hello, my name is Aditi. Welcome to re:Invent 2017.
A new Indian English voice. It adds to the already existing Ravina on our portfolio, and also based on feedback we received from customers, we chose to build a new voice of a more genuine and convincing Indian accent. All right. I mentioned earlier a number of times, I mentioned SSML, which is a W3C recommendation. It's an XML-based markup language dedicated to speech-based applications. And Poly is compliant with the standard, with this recommendation. It can allow you to, it allows you to control various aspects of speech, such as speech rate, pitch, volume. It can, it allows you to specify how to pronounce, how the voices would pronounce certain words in a certain way that is perhaps non-standard, and so on. And I will go through a number of examples now of how to use SSML. And this is a first simple to easy to use tag, which allows you to basically output the text that you want to synthesize, while underneath you actually tell the speech engine to pronounce a certain word in a different way. So in this case, actually there's a sample.
My favorite chemical element is aluminum, but Al prefers magnesium.
Right. The lang tag. You can think of applications, or let me put it differently. Similarly, as I mentioned earlier, in the case of Denglish, right, where you have intrusions, English intrusions in the common German language, you can think of all kinds of use cases for other languages as well, for the other voices. So in this example, Sebastian Kurz would be pronounced according, if not tag, it would be pronounced according to the English pronunciation rules. So not Sebastian, but Sebastian. If we mark that specifically as German, well, he's actually Austrian, but nevertheless, if we mark that as German, then the engine will use the pronunciation rules of the German language, and it will apply that. It will choose the right representation and then eventually the right sequence of phonemes to pronounce it a lot closer to German, to the actual German pronunciation. Let me demo that for you.
Sebastian Kurz, Austrian conservative set to become world's youngest leader.
Right. And obviously this can be applied to any combination of languages from the Poly portfolio of languages. Right. The expletive tag. It's a feature released earlier this year. It can be used to, to bleep words or phrases for certain audiences when certain content is not appropriate for whatever reason. I chose one of the longest, the longest words just to demo it more accurately. This is what it sounds like.
The longest word in English is
That was long. But Polly does a very good job, and the pronunciation of any text is very accurate. And so this word can be pronounced, accurately. We don't have to bleep it.
The longest word in English is pneumono-ultramicroscopic silicovolcanoconiosis.
We learn something every day. Right, another tag can be is very, very straightforward. Can be used to spell words out, such as handkerchief.
Here is how you spell handkerchief. Handkerchief.
Yeah, Polly doesn't have a problem with that. This is an example of how the rate and pitch attributes of the prosody tag can be used to do impersonations. Basically to change some of the characteristics of the voice, so that it basically resembles a whole new voice. And I use Matthew, the new one, which talked about himself as being great at doing impersonation of Batman.
Alfred, did you know there is a city called Batman in Turkey?
Yeah. I mentioned the Lexicon feature earlier, which can be used to create custom pronunciations for certain words. You don't need to be a phonetician or an expert in phonology to create that, to create entries into the lexicon. There are many resources out there that can, on the internet, that can give you really good hints of how to transcribe or give you the actual transcription of most of the English words, and not only English words. Polly supports both IPA, the International Phonetic Alphabet, and XAMPA. So there are two standards. This right here is XAMPA. So the lexicon allows you to customize pronunciation. So there's still debate whether GIF should be pronounced GIF or GIF. You can choose one and then consistently apply that pronunciation throughout your whole text without changing that every time this voice appears. In case of homographs, and specifically difficult homographs for a TTS system where there's no context, such as names, and especially in a case of foreign names. What's a foreign name in English nowadays? David versus David, but I will demo that as well. So that's the input text, and by applying these lexicon entries earlier, you get the following output.
I like this GIF.
That's without applying it.
I like this GIF.
And this is after applying it. And similarly for the second example.
Here's my friend David. Here's my friend David.
So default versus custom. Okay, and you can even have fun with SSML. We actually played a little bit, a number of occasions. We demoed, how much how many things can be achieved by just applying SSML. This is one of the great examples. Yeah.
I'm at 500 and I want 550 bid on 550. I'm at 500. Would you go 550 for the gentleman in the corner? A big black bug bet a big black bear, a big black bug bet a big black bear. Do we get 600? A big black bug bet a big black bear. We got 600 for the whole herd, sold for 600.
There you go. You don't need to get training for that. And it's just applying. This can be achieved by by simply applying a few attributes of the prosody rate, all within the speak tag, which is the basic document SSML document required by Poly. All right, and it is my privilege now to invite Andy Huntwork, the founder and CEO of the Magic Door.
Thanks.
And there you go.
Great. So this is going to be great because I lost my voice and then I spilled my tea on my shirt. So who can hear me in the back? You guys hear me? Okay, great. I guess we're doing okay. So I run the Magic Door, which is a fairly popular Alexa skill. And it's been, we built it almost 2 years ago at this point. And it was a side project, and it turned out to be much more enjoyable for customers than we expected. We've had 900,000 players. They've played for millions of minutes, 8 million minutes or more. And the way what it is interactive storytelling by voice. Here's an example.
Welcome back to the haunted lighthouse. Madame Pharaoh turns to face us.
Ah, yes. Now, you have a passion for adventure. Tell me, are you interested in a new challenge?
Okay, so that's from our newest story, the Haunted Lighthouse Adventure. You can play it by saying, Alexa, open the Magic Door. It's also available on other voice ecosystems. And so what we do is we tell stories by voice. And we use a combination of text-to-speech voices, including Amazon Polly, human voices, sound effects, background sounds, and foreground sounds. And we've just spent a ton of time over the last couple of years, just like hundreds of hours just sitting there playing with SSML to get just the effect that we want. So what I want to tell you about today is some approaches that you can use in your voice applications to use Amazon Polly most effectively. And also, the other thing that we have recently done is we thought that the audio engine for the Magic Door is this reusable component that makes basically Alexa skills, generally speaking, sound better. And so we pulled it out, and it's called TailStreamer. And you can use TailStreamer to create the multi-layered background sound, foreground sound type of effect that we use in the Magic Door, and apply it to your Alexa skill or anywhere else that you want to use Poly voices or just any kind of dynamic audio application. It has a RESTful API and also an interactive text editor, so you can kind of create audio files on the fly or through an API. So what we're going to do is talk about what we do in the Magic Door to take full advantage of Amazon Polly, and also how you could use our tool TailStreamer to create a multi-layered sound for your own voice application. Here's an example of something you could do.
Welcome to TailStreamer by the Magic Door.
You can add audible personality, branding, and emotion to your voice bot using TailStreamer.
We're all here to help. Let's get started.
So that's all generated by our markup language. There's a few inputs to that, obviously. One is some sound files. Another is we really like the wizard that we used in the Magic Door, and so he's that first voice. That's not synthesized. But after that, you can hear Amy, which was one of our favorite Amazon Polly voices, and then Ravina. And we'll be talking about Ravina quite a bit today. So that's kind of an example of TailStreamer. So here's how we use Amazon Polly for the Magic Door. So first, we have a lot of audio content that we've authored over time, and so we have a process. The first thing we do is we write a story, a branching story with a lot of choices and puzzles, like hidden object games, like you have to fix a machine by finding pieces, and a lot of different things that you can do with a voice-based game that's kind of a narrative style. So we do those things. We have a proprietary markup language that's XML-based that we use internally to represent the branching nature of the story. And then as soon as we've done that, we can kind of start previewing our story and just hear it in a kind of plain, basic default voice using Amazon Polly. And that sounds okay, but that's not where we end. At this point, we start adding sound effects. And then once we've heard like, doors opening and closing and footsteps and kind of the normal things that you would use foreground sound effects for, then we figure out which characters do we really need to have humans voice because they have a very particular sound, or they just need a ton of emotional range or something specific, and like the wizard, for example. And then we launch our story. And then what is most, I guess, important is that over the last couple of years, we've just constantly been iterating on our application all the time based on user feedback, like where are users getting stuck or what are they not really having fun with, and also based on analytics. Like we can see where they're getting stuck, and they could get stuck for a variety of reasons. One of them is like it's too hard of a puzzle, or the application is broken. Usually that doesn't happen. But then another is that our language model for our voice application does not understand the specific things that our output leads them to say. And so we can fix that kind of problem very quickly just by changing our content. And in fact, we just apply a lot of quick fixes to our content. We're just constantly doing that to improve the user experience. And this is why we just love using Amazon Polly. Because whereas a voice actor, you could get them to record it and it would sound good, then you're stuck. Like, hey, now you have to call that guy back again. And if he's sick or whatever, or he gets a different job, then I don't know, I guess you just re-record the whole thing, which we did at one time for the wizard and a couple other characters. It was annoying. But with Amazon Polly, they're always there. They never call in sick, and they sound great usually. So, and they let us, and we can do quick fixes, we can do A/B tests, we can do anything we want to. So that's our process. So what we're going to do now is we're going to walk through an example of how we in the Magic Door achieve a character that we wanted to build using the Amazon Polly voices. So let's listen to this example first.
While we walk over to the chairs, Madame Pharaoh sits down and plays us a tune. She turns to you, taking your closest hand into both of hers. She examines it.
Ah, yes. Now, you have a passion for adventure. And look at this. You are a good problem solver. Now, let me see. Aha. You are clearly very brave. My profound intuition tells me that yes, you two make a great team. Together you can do wonderful things and journey far. And I believe you two would be perfect for a particular challenge that needs solving. Tell me, are you interested in a new challenge?
Okay, so that's Madame Pharaoh. Maybe I should have said this before, but she's a fortune teller in our story. And you run across her before you've figured out that there is a haunted lighthouse, and she explains like the problem to you essentially. And she kind of tells your fortune, and then she kind of says you should go do this adventure, and you should save the pirate captain who's been marooned as a ghost in this lighthouse for hundreds of years, and you need to save him by fixing the lighthouse. So anyway, that's the story, and you can play by saying, Alexa, open the magic door. But that's the character, Madame Pharaoh, the fortune teller. So this is where we ended up. And so the question is, how did we get from the XML like that my wife wrote? By the way, I don't write the SSML. My author is my wife. She knows everything about SSML and all these characters, and so I say what she told me to say. But so here we are, and the question is, how did we get from the story that she wrote to the voice that ended up being what we think is pretty good? So the first thing we do, we kind of treat the TTS characters like people, and so we go through the process that we would go through if we were hiring voice actors, more or less. And so what we do is, first, we always, you need to know what characters you have to work with. And Amazon Polly gives us a lot of different characters to work with, and I'll show you some in a minute. And then knowing them and knowing the content, we cast TTS voices into some specific roles. And then finally, we can't just let them read however they want. we actually have to direct them and tell them how they should say various things and kind of correct them when they're not doing exactly the right thing based on the material or based on our vision, essentially. And that's kind of the process. So let's see how that works in practice. So I mentioned that we think that Polly has a ton of characters for us. And they do. They have 52 voices, I guess. Most of them are not in English, and our stories are exclusively in English. So actually, I think we have like 13 or something to work with in English. But what we found is that we can expand what Polly gives us by default a lot by using SSML to change the pitch and prosody, and more recently, by using the lang tag that Remus just told us about, we can create more characters by using foreign voices speaking English. And also we can use Polly's new feature, which is vocal track length, or timbre, to vary these voices even more, especially when we need child voices. That works out really well. So instead of 13, we have like, I think there's 40 on the slide here, and then there's 10 more that we've recently discovered with those other lang and vocal track length things. So we have all these options for which TTS voice to use. And so just as an example of the usefulness of this approach, we actually are very happy in many cases to have the same Polly voice playing two different roles, talking to one another with different prosody. So let's listen to one example.
Does the human not understand his own tongue? I said, the top barrel. If only my purse matched my love of dwarves.
Okay, so that's Brian, and that's some content from Rogue's Choice. So you can say, Alexa, open Rogue's Choice, and you'll get kind of an RPG-style dungeon crawler thing that we built with our partner Delight Games. It's pretty fun. You should give it a try. So that's Brian talking to Brian. Brian High is a dwarf, and Brian Normal is he's the hero of the story. His name is Rooster. And we think that's very different and not really confusable, and we're happy to have them talk to one another. So that's how we get all of our actors that we have to choose from. So in this context, we have fortune teller. And so we have a bunch of options like, hey, should it be Emma? Should it be Ravina? Amy's always good. So who are we going to really choose? So I mentioned Rogue's Choice. So we had worked with Ravina previously on a previous project, and we just love her voice, and we think it's very dynamic and adaptable and just great to listen to. So we cast her in this role. We thought she'd be perfect as a fortune teller. So that's kind of where we went. But let's hear it just the way she speaks it by default, just to see where we start for the next step.
Ah, yes, now you have a passion for adventure. And look at this, you are a good problem solver. Now, let me see. Aha, you are clearly very brave. You know, my profound intuition tells me that yes, you two, make a great team. Together you can do wonderful things and journey far. And I believe you two would be perfect for a particular challenge that needs solving. Tell me, are you interested in a new challenge?
Okay, so just let's stop there and just say, like, Ravina sounds awesome by default. And if we were to stop there, it might actually be okay, because it's just a great voice. But there's a few problems. One is that she's a fortune teller, and she's telling her fortune. She's like reading your palm, and she's communing with spirits or whatever she's doing, and she's just talking way too fast to convincingly say that she's actually like applying her profound intuition or doing any of those things. So at least we just need to slow it down a whole bunch. And then also, we need to add some deliberation. We need to add some some puzzle. She's puzzling about this, right? She's really thinking. So we need to add that kind of emotion to it, or like that intonation at least. And then maybe we can have a convincing fortune teller. So that's what we kind of try to do. And so that's just for this character. But the techniques that we apply here are pretty general, and we use them like throughout all of our stories. We always, even when we're not trying to create a very particular character, these techniques I'm about to tell you about, they're like, we always do them, and we feel like basically all voice applications should apply at least the first two techniques to sound better if you're speaking more than like a couple sentences at a time. So let's go through some of these. So the first thing we do often is that we punctuate for voice. Usually, by default, when we're writing, we punctuate for writing. And there's grammatical rules for that, and a period is at the end of a sentence. But when you're punctuating for voice, period means something a little bit different. Period mostly means like a hard stop, and comma mostly means like a shorter stop. And so so the first thing that we do is we listen to it, and we remove commas where they're creating pauses that shouldn't be there, and we turn commas into periods or periods into commas, so that we get approximately the right pace for voice. And those are kind of different rules actually. So this is important. And if you do this enough, you don't have to listen to it before you do this. You can just kind of just say, yeah, I know that needs to be a period instead of a comma, and you kind of get a little bit good at it, and so that's good. That's important.
Yes. Now you have a passion for adventure. And look at this. You are a good problem solver. Now, let me see. You are clearly very brave.
Okay, so at least in my opinion, we're starting to get kind of like the right pauses at least to indicate where she's stopping to think and kind of like looking at your hand or whatever she's doing. And so that's good, but it's still, it's not right. And also, we introduced a little audio defect between now and you. It sounded a little bit broken. Now, it didn't sound like that when we just let Ravina do her thing. It sounded great, and she didn't make any audio errors. But now that we're kind of messing with it, it's kind of like you mess with it, you own it, you got to fix it sometimes. And so we're happy to do that. And so the way that we fix the error is by using the phoneme. Well, we use phoneme tag to spell out how we want it to sound, so that we can fix up the audio defect that we caused by messing with it too much. So here we kind of use phonetic spelling. This is ex-sampa. It's the same one that Remus showed us, the same approach to spelling things out phonetically. So that's how you spell out you in ex-sampa is %ju. Okay, so so that's the first thing we do. We fix that audio defect, and we'll listen to it in a second. But and then the next thing that we're going to start doing, and again, this is like, we didn't start out putting break tags all over the place when we first started writing stories a long time ago. But now we realize that it's so important that we've gone back through all of our old content and just added breaks in, and it makes just a clearly perceptible difference in whether our story is comprehensible and whether users are able to keep up. Once you get past a couple sentences, the speech rate that works well for reasonably short prompts, you kind of need to let the user catch up. And breaks are one of the main approaches that we use that just really make it work really well. And so 300 millisecond pauses, half-second pauses. When we're using background sound, having a full-second pause to let people kind of like absorb the environment and kind of listen a little bit. But a lot of half-second pauses here and there actually are important. They're like, you should do this. If you're building a voice application, you should definitely do this.
Yes. Now you have a passion for adventure. And look at this. You are a good problem solver. Now, let me see. You are clearly very brave.
Okay, so we're making progress. We're not quite done yet. We've started adding like more of the right kind of like, where does she stop and think sort of feeling to this, at least, in our opinion. And so that's where we are. And we did fix up the audio problem, so good progress, yay, go team. And but the next thing that we do, and this is not critical to do all the time. This one we use in specific circumstances when we're really trying to create a very particular feel. The first two we use like everywhere, all the time. And this one, in specific cases, is we use prosody. And we almost always, prosody, Remus showed us, can make things talk really fast, and you can become an auctioneer. What we find in our kind of longer form storytelling mode is that we're always slowing it down. Like actually, just, maybe a takeaway is we're always slowing down the interface. And, a lot of people might tell you that terse voice interfaces are like really important. It's important to be terse. And we kind of agree that it's important to be terse, but it's also really important to kind of make sure that your user has an opportunity to absorb what you're telling them. And that, for us, very often means slowing stuff down a little bit. And so we're throwing in slow and extra slow prosody along with normal to kind of give a varied feeling, like a varied rate of speech to this character, which is important given the context because she's thinking about it and she's pondering, and also to just create some natural variation in her speech. So let's listen.
Ah, yes. Now you have a passion for adventure. And look at this. You are a good problem solver. Now, let me see. Aha, you are clearly very brave.
Okay, so to us, this feels like progress, like a lot of progress. In fact, I think this is the last slide. So that's the progress that we made with SSML by applying those techniques, which are fairly general, and if you're using Poly, you should, we think, often use them. So, but again, like you heard the initial presentation. It wasn't just Ravina. It was actually kind of the overall effect was background sounds, two different characters put together, and everything together. That's how we, that's the scene. The scene is multi-layered and rich audio experience. So we use TailStreamer to kind of put it all together. And TailStreamer is our markup language for adding background sounds, foreground sounds, and multiple voices using Amazon Poly. And we have this composer thing that does syntax highlighting and some other things. And you can, as the author, you can hit that play button anytime you can see the play button. You can hit that play button a lot, actually, as you're doing voice editing. And then when you're ready, you can download a file if you want a file. But you could also, we have an API, so you can also just put this into your content management system and render it at runtime or whenever. Because the API is fast, it streams audio out. It generates it as it streams it, kind of like the TTS engine that Remus was mentioning earlier. And so this is how we assemble the final rich multi-layered scene. And so I guess that's the end. Oh yeah.
While we walk over to the chairs, Madame Pharaoh sits down and plays us a tune. She turns to you, taking your closest hand into both of hers. She examines it.
Ah, yes. Now, you have a passion for adventure. And look at this. You are a good problem solver. Now, let me see. Aha, you are clearly very brave. My profound intuition tells me that yes, you two, make a great team. Together you can do wonderful things and journey far. And I believe you two would be perfect for a particular challenge that needs solving. Tell me, are you interested in a new challenge?
Yeah, so that's the end. And so, yeah, that's pretty much what I have, actually. So thank you. I guess we will take questions. Any questions, let us know. Actually, if you wouldn't mind, I don't know if you're required to use that microphone or not, but if you wouldn't mind. Could you use a microphone? I think because we're being recorded. I'm sorry. It's annoying.
Oh, okay. Are there any tools to take speech to text and then apply SSML to it? So you've got the text form and it layers in the SSML stuff you spoke about.
Sorry, the question is...
So you have speech to text.
Yes.
But as it's converting it to text, it layers in the SSML, so it's actually it understands the way it's been spoken and layers in those
right.
Oh, like
tags.
with phonetic spelling and when it's not sure of the actual word, actually put in phonemes. That's a pretty cool idea.
I am not fully, so the speech-to-text service was just launched. I'm not fully familiar with all the features of that system. Yes, so I can answer that. I'm sorry, I can answer that question.
Thank you. Thanks.
Go ahead.
Hi. Have you found much difficulty in your storytelling generating sounds like nuances in speech when somebody's searching for a word where they're saying or or
Well, yes. We can actually, we can achieve that actually with SSML a lot of the time. And so it's difficult, but we can do it. And also, often we're using Alexa's voice, and she has speech cons, like there's some speech cons for Alexa's voice. And so you can get her to say things like, oh gosh, or something in a fairly kind of crazy way. So yeah, it's not that easy.
Thank you.
Over here.
Yeah, at one of the skill sessions, I talked to an engineer about the lexicons and adding in like a public lexicon to do industry-specific terminology. So say I'm in pharmaceuticals and there's a lot of brand names, those kinds of things that it's reading that are sort of specific to an industry. What's your experience with combining the lexicon with the SSML? And do you have any kind of experience with that?
Sorry.
Are there? I think the question is like, are there open source?
Are there open
source lexicons for like domain specific things?
I am not aware of any domain specific lexicons that are available out there. The only resource that we sometimes also look at is about the Wiktionary. It's probably not exactly what you were asking for, but I think there might be some overlap as well.
In SSML, you obviously have some of these prosody tags and the rate to slow it up and so on. So these are in some way very low-level primitives, right? Does the SSML roadmap have the idea of adding higher-level tags like, say, anger or happy or things like that, which should automatically change the prosody and so on?
Sure. So as you've noticed, that is not yet a feature we support. But we continuously work on adding new features to Poly, and that is feedback that we'll take back to the team. Thank you for your input.
Yeah, because in a way, all the things that he showed, right, like being thoughtful, being deliberate, which really just translates into a certain other tags, right? So you need higher level abstractions.
Yes. I'm sure Andy would be really happy with that kind of feature.
Yeah,
we're aware of that.
On one level, we know that we're doing something that, there's an emotional aspect, but then there's also just a very content specific and use case specific part of what we're doing there in terms of like being thoughtful about what, and so some higher level tags are great, but then then instead of using prosody, we'll have to use some higher level tags, which we're happy to do. But so what we're doing with TailStreamer is we're creating this styling language on top of SSML and audio and everything else that helps us worry about like volume and rate and things like that, and actually voice selection. So like whatever the underlying TTS primitives are, we see that as being like a CSS kind of thing,
sure.
Where in this context we want it to be loud or we want it to be slow or something like that, and we'd want to separate that from the content, just as another way of looking at the problem.
Right. I'm just saying, instead of writing an instruction code, it'd be nice to write in a higher level language, right? So that kind of stuff.
Yes, that would totally make us happy.
Thank you. Yeah.
Thank you.
Yeah, I did essentially the same question, but I was wondering if you had found any tricks using the tricks you do have, which could make it sound angry, since it is in a higher level.
Angry. Let's see. We noticed that mostly our characters don't get angry. That's except we had a human character that got angry. Yeah, we do excited. We want excited, and that's actually pretty difficult to achieve. And so we use we use holy guacamole in some contexts because it sounds like you're excited even if the TTS voice isn't really super excited about it. And we use that one sometimes. So actually adding emotion to it's hard. Actually, it's pretty hard. And that's when we call the humans, actually.
How do you keep the conversation on the tracks per se when somebody says something completely unexpected?
That's error recovery and like conversational error recovery. And we have a very simple approach, which is we just tell them that that's not something you can do, and then we give them hints. We have like an evolving, rotating set of hints we give when people give us instructions that we just can't deal with. And then also we look at our analytics and figure out what people are actually saying, and then we go back and we provide custom answers for things that we can't do but we know people are doing a lot. Like when people answer riddles incorrectly but with the same answer all the time, then we're like, oh, okay, well that's, I guess, a very understandable thing that we should provide a reasonable answer to, not just say that's not something you can do here, which would be annoying.
I see. Thank you.
Great talk. I also got a question. Basically, the examples you showed were just a highlight where you try to achieve a special effect, and most of the time you're just using the standard words, or do you do this with every sequence? And how much time do you put in that? Is it then still cheaper than basically having a professional speaker speaking this?
So, great question. We look at it a few different ways. One is that we always spend a little bit of time on like breaks and pauses and just spacing it out and slowing it down a little bit. We apply that across like all of our content basically. And even, yes, so we do that. But that's actually really fast and easy to do, especially once you kind of do it a few times. So then the question is like, how much time do we put into this particular segment, which is very rare in the amount of time that we put into this particular. This was the most complex SSML that we found in all of our tens of thousands of lines of story content. This was the most complex one. This one took, this was probably like 3 hours or something like that, 3 or 4 hours of just kind of like playing around, I would say. And so for us it was worth it because we really thought we could achieve the right effect at the end, like we're pretty sure because we love Ravina and we thought she would be perfect for this. And then also we have complete control over how we change it. And actually we did change it. We chopped up scenes, we moved things around. And so that level of flexibility for us, which we even apply after production, is worth some, is absolutely for us worth some upfront time. But then I would say, like, we also have a wizard character in the same story, and we really, based on our experience, there was no hope that we would get a great result for a wizard with, so we just hired a guy, and that was best money we spent. Like, best money we've spent on the Magic Door is on a few voice actors here or there. They make a huge difference in specific contexts.
Thank you.
Yep.
I have a question. Poly is amazing, and but still it sounds a little bit unnaturally, and I wonder because human speech is very. Intonation can change every millisecond, for example, and it will be very difficult to put something like this using this ML language, XML. So do you have any insights maybe on how this problem could be solved, like to make it sound more naturally without putting a lot of, changing intonation of every letter, for example?
Sure. So we'll not go into the details of what exactly we are planning to do. There's a full roadmap on stuff that we will attempt to research and eventually apply to our voices. But yes, there is effort, there is constant effort, ongoing effort to improve that aspect as well, and to get as close to as possible to that type of experience out of the box. And I mean, obviously, out of the box, you won't be able to create a fortune teller's voice, but in terms of naturalness, there will be, stay tuned for more improvements likely to come.
Thank you. And I wonder, do you have like a Turing test for voice? Like if you don't see the speaker?
We certainly, it's a version, let's call it, of the Turing test. We do our internal benchmarking, and our reference is the original voice talent with which we record the data used for training a voice, right, for building a voice. And yeah, we do want to get as close or above, more natural than the original voice. We're close. We're pretty close.
Sorry if you've spoken about this in the beginning because I came late, but if you want to emphasize one word in the sentence, which is really important in English especially, how can you do that? Because if you have, for example, the sentence, "This is not a blue car," you can say, "This is not a blue car, this is not a blue car," or "This is not a blue car." And how do you cope with this kind of problems? Because I've been trying to use the emphasis tag, but it doesn't really work. It doesn't really sound naturally. So is there any other way?
Sure. So yeah, that would have been my suggestion. To try to use the emphasis tag, which I mean we are aware that it doesn't always get the exact expected output. And there's also...
Is that because there's multiple different types of emphasis and
that's
just one tag?
That's one of the things.
Okay, that's our experience.
Yeah, and I mean, the output of text-to-speech is so much dependent on a specific context, right? And depends a lot on how the voice itself has been trained. So... there is ongoing work to improve that part as well. Right now, it's...
But until now, you'd say like to combine maybe the pitch and
right.
And
yeah, so you should try that. That works.
Absolutely.
That's what I've been trying, but it's usually very, very difficult to combine all these tags to...
Why don't you send it to me? I'll take a look.
Sorry?
Send it to me. I would be interested. So email me.
There's this new feature Andy mentioned earlier. That you could experiment with that as well. The changes in vocal track length. That to some extent could be applied to see if you can create the effect of emphasis in certain contexts there.
Okay. Thanks.
Cool. Thank you, guys.
Thank you very much.